right, so today we're looking at surface area and volume of prisms. So to start off, we're just looking back at where we left off in class. So what makes something a prism? It's a type of polyhedron, so all of the faces are polygons. They have edges with two parallel and congruent bases. So here in my example, these are your parallel congruent bases. Since these bases are parallel, those lateral edges that connect them, so here's a lateral edge right here, has to match every other lateral edge. They have to be congruent. All of those side faces here that wrap around, those are your lateral faces. They have to have four sides. They're all quadrilaterals because they're made up of base edges and lateral edges. Okay, lastly, if a prism is right, those lateral faces are rectangles. If oblique, those lateral faces are parallelograms. All right, so our focus here is on right prisms. Let me write that down. And then looking at a three-dimension model right here, and then a model that's in 2 dimensions. So here is the net of it. Our base shape can be any type of polygon. In my model here, I'm making my bases hexagons, more specifically regular hexagons, if I gave you those markings. And then these are all of my lateral faces. So when I picture my surface area is this lateral area, all of those side faces, plus 2 base areas. Now again, my base can be any shape. In my model here, I'm making them hexagons. So my lateral area, I can actually be more specific because I'm really trying to picture this big rectangular chunk. So right here is the height. That would be like the height of my prism in 3D. This is that perpendicular segment that's going to connect my 2 bases. And then right here, this whole strip has to wrap around the base. So this whole part right here ends up being the perimeter of the base. So I can think of my lateral area really as this big giant rectangle where I'm looking at the height of the prism times the perimeter of the base. So I'm going to get more specific here and say HP plus 2B. So again, that's the height of the prism times the perimeter of the base plus 2 base areas. And again, our base area can be any shape. In this case, it's a regular hexagon if I tell you that all of these sides are the same. Okay, volume is always just whatever the base area is times the height. Okay, if I'm looking at a cube, the formal name is hexahedron. We know that really a cube is a type of right prism, but we have 6 congruent square faces. So all of our sides are the same. I'm going to call them all x. So then if all of the sides are the same, all of the sides, the squares, have an area of x times x. So each of those squares has an area of x times x, x squared. So when I think of my surface area, I really have 6 perfect squares. Each one has an area of x to the 2nd power. So I have 6 squares, 6 times x squared. Remember that x right here is just a side length. So really I'm thinking of 6 times a side length squared. Okay, volume base area times height, but our base area is x squared. So x squared times x would be x to the 3rd power. So volume of a cube is just a side to the 3rd power. Okay, one other thing to point out before we go deeper is that the right prism, that formula would work here too. Okay, so again, a cube or a hexahedron is still a type of right prism. Just more specifically, all of the faces are perfect squares. So we have a little shorter formula to navigate for surface area and for volume. All right, a little bit more review. So here we derived this in class the other day. So if I'm looking at the diagonal of a right rectangular prism, here is my diagonal, right? I'm connecting opposing vertices, and I'm really visualizing this right triangle inside of my 3D shape. Okay, and what we derived is that the diagonal is equal to the square root of length squared plus width squared plus height squared. We really derived that formula by using the Pythagorean theorem twice. All right, next some examples. So first I'm telling you that a cube has a surface area of 294 square units. Find its volume. So I'm given surface area, 6 times the side squared, but I want to get to volume, x to the third power. So I can build an equation where I can find the side length. I know that 6x squared equals 294. I want to solve for x. So I'm going to divide both sides by 6. So x squared equals 49. And then I'm going to solve by taking the square root. So x could be plus or minus 7, but we know that it's a side length. It has to be the positive. So I'm only looking at a positive 7. So when I plug in here, I want 7 to the third power. And 7 times 7 times 7 gets me 343. Now volume we always express as cubic units, units cubed, because we're looking at the number of non-overlapping unit cubes that fill up a figure. Okay, example 2, I'm giving you a cube with a volume of 512 cubic units. We want surface area. So again, volume is a side cubed. Surface area is 6 perfect squares. So 6 times x squared. I need to find a side length. So I know that x to the third power equals 512. So if I want to solve for a side length, I need to take a cube root of each side of my equation. So now x is going to equal, when I look at 512, 512 is 64 times 8, and then 8 times 8. So cube root, I'm looking for 3 of the same, and I see that group of 3 8s. So my side length is just 8. The cube root of 512 is 8. So I plug that back in over here. So 6 times 8 to the second power, 6 times 64, and I get 384. So 384 units squared. So surface area, it's like wrapping paper. We're looking at the number of non-overlapping unit squares that cover a figure. All right, next up. Find the surface area and volume of a cube with a side length of x times the square root of 2 units. All right, so surface area, we have 6 times x root 2 as a quantity squared. Volume will be x root 2 as a quantity cubed. All right, so when I look over here for surface area, I have to distribute that exponent of 2. So I have 6 times x to the second power times 2. Right? When I square a square root, it gives me the pair underneath the root and becomes just 2. So really I have 6 times 2x squared So 12x squared. So surface area is 12x squared. Units are squared. Okay, volume, again, I'm going to distribute that exponent. So that gives me x to the third power really fast. But really, root 2 times root 2 times root 2. It's like putting 2 under the radical 3 times and looking for the square root. So I'm looking for pairs. I see this group of 2. So I'm going to pull out that group of 2, write 1 on the outside to represent the pair that was underneath. So I have 2x to the third power and then square root 2 because that 2 stayed behind. So my volume is 2x to the third power, root 2, units are cubed. All right, next I'm saying, can you find the diagonal of a right rectangular prism? Here's the length, the width, and the height. So remember that our diagonal formula is the square root of length squared plus width squared plus height squared. So I'm going to plug everything in. Big square root, 3x quantity squared plus 5x quantity squared plus 9x quantity squared. Now I have to distribute all of those exponents. So now I have 9x squared plus 25x squared plus 81x squared. Those are all like terms. I can consolidate and get 115x squared. So now I'm looking for pairs of the same thing. I'm not going to find it in 115, right? That's really 5 times 23. There's no pair of the same thing there. But I will see a pair of x's. So my answer will be x times the square root of 115 units. All right, we have 2 more on this page and then we'll do a little flip. All right, can we find the side length of a cube if we know the diagonal? So again, let's start with that formula. Diagonal is the square root of length squared plus width squared plus height squared. Now we're saying that the side length, it's all the same. Length, width, and height, they're all the same. So let's just call them all x. So 6 equals the square root of x squared plus x squared plus x squared. So now 6 equals the square root of 3x squared. So maybe here I see, oh, I have a pair of two x's right there. So 6 equals x root 3. And then I want the x all by itself, so I can divide out the root 3. And then I rationalize, multiply by root 3 over root 3. So now I have x equals 6 root 3 over 3, which then becomes 2 root 3. That works. My side length must be 2 root 3 units. Okay, but there's another way I could have done it. Let's say that I go back to this stage. I'll say or 6 equals the square root of 3x squared. So I could have, at this stage, since my root is isolated, I could have squared both sides. So now I'm at 36 equals 3x squared. Divide by 3. X squared equals 12. And then solve by taking the square root here. And I would get x is plus or minus 2 root 3 a different way. And then again, we're only taking the positive. So our positive solution, right, a positive side length has to be positive 2 root 3. All right, next one here in 6. Find the width of a right rectangular prism. Our diagonal is 10, length is 2, height is 6. So same formula, I'm just going to plug in my parts. Diagonal is 10, square root, 2 squared plus width squared plus 6 squared. I'm trying to isolate that W, my width. So square root 4 plus the width squared plus 36. Keep consolidating the like terms. So now I have 10 equals the width squared plus 40. But now I'm stuck. I have to remember that what is underneath my radicand is a package. It's joined by an addition sign right here. So I'm at the stage where I have to unlock the square root by squaring both sides of my equation. That is going to unlock the square root, give me a pair underneath that square root, underneath that radicand right here. So now I have here 100 equals, here again I get my pair of the same thing under the root. So 100 equals w squared plus 40. Take away the 40 from each side. My width squared equals 60. Solve by taking the square root. Simplify that 60. That's 4 times 15. So I get a width of plus or minus 2 root 15. But again, I'm only going to take the positive. I can't have a negative measure. So my width is 2 root 15 units. All right, let's flip it over and look at the back. All right, so here I'm giving you different right prisms. Some I'm giving to you in 3 dimensions, and some of them I'm giving to you as a net. So the key to all of these is to figure out how to get to the right base area. If I can't get base area correct, I'm not going to get the surface area or the volume correct. So in this first one, I'm saying the base is an equilateral triangle. Each side is 6 units. So I'm going to take a moment and flesh out my base. So here's my equilateral triangle. Each side is 6. I know that I can split an equilateral triangle right down the middle, and I can make 2 congruent right triangles that are 30, 60, 90 triangles. So I know that my short leg is x, my longer leg is x root 3, my hypotenuse is 2x. So I end up with a 3 right here and a 3 root 3 right here for the height. I don't want to forget though that my full base is 6. So my area of my base, half base times height, is half of 6 times 3 root 3. And if I multiply that across, half of 6 is 3 times 3, and I'm at 9 root 3. My units are squared. All right, surface area. So surface area, I have to get to all of my lateral area, those side faces. That is the height of the prism times the perimeter of the base plus 2 base areas. So the height of my prism right here is 15. The perimeter of the base, right, all of these sides are 6, and I have 3 of them. So 18 plus 2 base areas. I just solved for that. Each one is 9 root 3. All right, so now multiply it through. So we're going to get 270 plus 18 root 3. I can't combine, those are not like terms. So 270 plus 18 root 3, units are squared. Okay, volume. I'm looking at my base area times the height. So base area is 9 root 3, and the height of the prism is 15. So I need 9 times 15. That's 135 root 3. Units are cubed. Right? Volume is always units cubed. All right, first one is done. Next one, we have an isosceles trapezoid as the base. Let me slide this over a little bit. So here again, I'm looking at that base shape first. That's the key to all of this. I have to get the base. I need to find that area correctly, because if I don't, I'm going to mess up surface area and volume. So I'm going to take a moment and draw out the base. So I have a 6, a 12, a 9, and a 9. And I'm going to section off these two portions and make those congruent right triangles. Let me zoom out a little bit so I can see that top base. All right, so I can see that that is 6. All right, so that 6 would slide down right here. And then I have 12 minus 6, so I have a 3 here and a 3 here. So if I need to find my height, which I need to do first, so finding the height of the trapezoid, right, that is a leg of this right triangle. So my shortcut, my height, a leg, is the square root of the hypotenuse squared minus the other leg squared. So that ends up being 81 minus 9, so root 72, right? That's 36 times 2, so 6 root 2. That's my missing height. All right, so I'm good there. Now I need the area of the trapezoid. So I know it's the average of the two bases times the height. So half of 6 plus 12 times 6 root 2. So half of 18 times 6 root 2. So if I multiply that across, half of 18 is 9. 9 times 6, I'm at 54 root 2. So base area is 54 root 2. Units are squared. All right, I still need my surface area and then also my volume. So surface area, I'll tuck that in here, HP plus 2B. So again, the height of the prism times the perimeter of its base. It's really looking at this chunk right here, this lateral area, as this big rectangle. So it's seeing that right here, that side of 9 connects right there. Here 6 right there, and then here the other 9. So again, picture your bases as two flaps that fold down, and all of those lateral faces fold around it to make it go 3D. All right, so height of the prism right here is 4. Perimeter of the base, if I add all these up, that's going to combine to 36. And then I have two base areas. Each one is 54 root 2. So 4 times 36, I'm at 144. And then 108 root 2. Again, not like terms, so I'm going to leave it just like that. 144 plus 108 root 2. Units are squared. Okay, volume last. We got room right here. So base area times height. So we're looking at 54 root 2 times the height of the prism, which is 4. So 216 root 2. Units are cubed for all things volume. All right, another example. Let me slide on up. So here we're essentially told that our base shape is an isosceles right triangle, or a 45, 45, 90. So again, let's take a moment. Let's draw that off to the side. And the hypotenuse is 6. So remember that the two legs are x, and that hypotenuse is x root 2. So if I take half and multiply by root 2, my two legs are both 3 root 2. Now for any right triangle, I can always use the two legs, the perpendicular sides, as my base and my height. So half of 3 root 2 times 3 root 2. That's like saying half of 3 times 3 times 2. Half of 2 is 1. So really just 3 times 3. My base is 9 square units. All right, so then moving on to get to surface area and volume. Again, I'm just going to zoom out so I can see it all in the same spot. All right, so now I need surface area. So HP plus 2B. Height of my prism times the perimeter of its base plus 2 base areas. So the height of my prism right here is 7. Perimeter of the base, right? If I add up all these sides, I have 6 plus 6 root 2. 2 bases, each area is 9. So 2 times 9. So now I distribute that 7. I get 42 plus 42 root 2, and then plus here 18. I can only combine my like terms, so that 42 and the 18 get me 60 plus 42 root 2. I can't go any further than that. But units are squared always. Okay, volume to close it out. So volume base area times height. So 9 times 7, and we get 63. So 63 units are cubed, always for volume. All right, so we should be good there. Okay, next one here. The base is a regular pentagon. The apothem is 4 units. Okay, if we need to round throughout the problem, then we're going to round to the nearest 10,000th, 4 decimal spots. I usually try to model for you rounding at the very end. So again, let's look at the base. Let's check out that base first. So a regular pentagon looks like this. And we're told that the apothem right there is 4. So center to a side, that perpendicular segment is 4. So here I need to figure out an angle of this right triangle because I need to get to my area of the regular polygon. So I'm going to need my perimeter. I already know my apothem. So if I want this angle right here, that's usually what I model. That's half of a central angle. So half of 360 divided by 5. My shape is a pentagon. So then half of 72 is 36 degrees. So this measure right here, half of a central angle is 36 degrees. I could also get this one, half of an interior angle, that would have been 54 degrees. But building off of this one, I now need to solve for x. That's going to lead me ultimately to my perimeter. All right, so then I have to use a little trigonometry in order to get to that measure. So here from this angle, this is an opposite, this is an adjacent side. So I know that tangent 36 equals x over 4, right? My opposite over my adjacent. Picture it as a proportion, cross multiply. So x equals 4 times tangent 36. And that's going to get me 4 times tangent 36, 2.9062. But remember, that's half a side. I need my whole perimeter. So I have 10 half sides. I'm going to multiply that by 10. So my perimeter is 29.0617, right? That is my perimeter of that base. So now if I want area of my base, 1/2 apothem times perimeter, I'm saying half of 4 times this perimeter that I just solved for. So if I keep it nice and precise in my calculator, I can say 1/2 times 4 times that previous answer stored. And that's going to get me 58.1234. That's my base area. And I'm only rounding at the end to the nearest 10,000th, 4 decimal spots. All right, so I'm good there. So now if I build off that to get to surface area, slide that up a little bit, HP plus 2B. So height of the prism is 20. perimeter of the base, that's what I solve for here. So 29.0617 plus 2 base areas right there, 58.1234. Okay, that's going to get me about 165.31 units are squared. Okay, last thing I need then is volume. I'll tuck that in here. Base area times height. So 58.1234, height of my prism is 20. So when I multiply those two together, I get 1,162.48 units are cubed. I'll write that up here too. All right, one more problem, then we'll call it a day. So lastly, here I'm saying that the base of a right regular hexagonal prism has a perimeter of 72, a little tighter, and a volume of 1,723 or 28 root 3. So 1,728 root 3 centimeters cubed. We want the height. So when I think about what my formula is, right, for volume, volume is base area times height. So I know the volume. I know it's 1,728 root 3, and I want the height. So I'm going to need to figure out what my base area is, and I have enough information to do so, right? My base is a regular hexagon, and I know its perimeter. So let me sketch out that base. So if my perimeter is 72, if I divide that 6 ways, each side is 12. Draw in the apothem and a radius like so. We know that the regular hexagon here has a, right in here has an interior angle of 120. So if I split that, I get a 60 here and a 30 here. So I see a 30, 60, 90 triangle where this is x, this is x root 3, this is 2x. So half of a side is 6, and then my apothem must be 6 root 3. So my area, half the apothem times the perimeter, half of 6 root 3 times 72. Half of 6 is 3, 3 times 72, I'm at 216 root 3. That's what I'm going to plug in right here. 216 root 3, and then here's my unknown height. So again, I know my volume. I had enough information to find my base area, and now I'm trying to solve for my height. So I really just have to divide out that base area that I just solved for. And when I divide something by itself, right, that's 1. Root 3 over root 3 is just 1. So I need to take 1,728, divide it by 216, and I get a height of 8. So 8 centimeters, that is my unknown. All right, that's all I have for today. Have a good rest of your day.